we want to look at converting from base 10 to base 2. Last time we were looking at converting from base 2 to base 10, where what we did with the base 2 number was to write each digit, write each digit and multiply each digit by 2 to the power, and we added them, right, and so on and so forth. You separate the digits, multiply each digit by 2 to respective power, and add them all up, and what you got was your equivalent base 10 number. What we want to do now is convert the other way around from base 10 to base 2 to get our base 2 number. Basically, the method that we're going to use consists of really dividing the number by 2. We write the answer, what we get, answer and remainder. After that, you bring down the answer, and that you divide by 2, and you keep the process going like that. So basically, this method will consist of dividing by 2, dividing the number by 2, writing down the answer and remainder. Bring down the answer, divide by 2, write down the answer and remainder. Bring down the answer, divide by 2, write down the answer and remainder. Finally, when we're done, you're going to read the remainder up from where you finish up to where you start. So basically, let's try with one of these numbers. Which number we want to try with now? Say 13. This was really 13, you know. 13. These are 3. 13. So 13, which we're supposed to end up with according to this table, is 1101. So let's see if we do it, if we're going to get that right. You divide by 2. Divide by 2 because you're trying to convert to base 2. If it was to base 4, you would divide by 4. If it was to base 8, you would divide by 8, and so on and so forth. So we divide by 2 equal the answer. What's the answer here? 2 into 13 goes 6 times, and the remainder is 1 remaining. So in 13 there are 2 2s and 1 left over. Then you bring down the answer. So I'm going to bring down this 6 and put it right here. So this is 6. Repeat the process. Divide it by 2. You get an answer. The answer is 3. What's the remainder now? It's 0. Okay. Let me bring down this answer. The answer 3. Repeat the process. Divided by 2. 3 into the 3 divided by 2, the answer is 1. What's the remainder? It is 1. Okay, this is the answer. We bring down the answer. I wonder at what point we're going to stop. Are we going to just go on and on and on forever? Let's see. Bring down the answer 1 divided by 2. When you say 1 divided by 2, well, 1 is smaller than 2. So you put a 0. What's the remainder? The remainder is 1. Okay, let's go on. The answer is 0. The 0 divided by 2, is 0. What's the remainder? 0. If we say 0 divided by 2, the answer is 0 divided by 2. 0 divided by 2 is 0, remainder 0. But wait, aren't we just repeating ourselves, wasting time and ink and energy here? We're going to just keep the thing 0. So it doesn't make sense going beyond this point. So might as well just stop here then. Right? Once you get an answer 0, that's where you stop, because you're going to keep using the same 0 and keep getting zeros. Alright, so we stop at that point. Doesn't make sense to go on any further. Now, you read upwards. You read up. So the answer that you're going to get for the binary will be these digits. This first, you have a 1, and this here 1, and this 0, 0, and this one here 1. So basically this is base 2 number, the equivalent for 13 in base, well, I don't need to write the base 10. 13 in base 10 equals 1101 in base 2. That was the case here, 1101 in base 2. Alright, so basically you have a base 10 number, you want to convert it to base 2. You divide that base 10 number by 2. It's base 2, you're converting it to 2. Divide it by 2. You get an answer. Write down the remainder. The remainder will always be 1 or 0. Bring down the answer, divide by 2. You get new answer. Write down the remainder. That answer divide by 2. Bring it down, divide by 2. You get new answer. Write down the remainder. That answer you got a while ago, divide it by 2. You get new answer. Write down the remainder. And you go on and on and on until when you get an answer of 0, and you're going to get a remainder 1. Well, if you want, you could continue, but you'd only be wasting time getting zeros. So you might as well stop when you get an answer of 0. Then you read these digits upward and you get the binary equivalent. Alright? So I want you to try the same procedure with other numbers and see if it works out. I will see you later.